Pure exchange model is undoubtedly the simplest model of an economy that we can construct. We are going to be talking about two people coming together and trading apples and oranges with each other. But one of the things you're going to see here pretty quickly is that despite this being about as simple a situation as we can imagine in economics, to explain it completely, we're going to need to make a bunch of assumptions, and we're going to create some diagrams that can be challenging to understand exactly what they mean. So I'm going to start with a set of assumptions. Again, this is a deductive exercise, so here's what we're going to assume in our pure exchange model. Number one, we're going to assume that there are two people. We're going to call those two people Smith-Jones. Okay, so simple assumption, two people in an economy, and that's all there is. So we don't have to think, this is an example where once we make an assumption there are only two people, you should never consider in the context of this model, well, what if there's 3 people or 4 people or 10 people or whatever? If you do that, you're creating another model, another story to tell, all right? So stick within the assumptions of the model, and then we'll see where we go from there. Assumption number 2. We're going to assume that there are 2 homogeneous goods, apples and oranges. So we're going to use A whenever we want to refer to an apple. We're going to use a subscript or superscript O in a variable whenever we want to talk about oranges. All right, now Smith, we'll use S to represent Smith's name, J to represent Jones's name. So again, we're going to start using letters to simplify the description of the components of this model. Now the goods are homogeneous. Let me explain what that means. Homogeneous or homogeneous, you can pronounce it either way. Homogeneous goods are identical to each other. They're all the same. Now, I'm not saying the apples are identical to oranges. What I'm saying is that all of the apples are identical to each other. And by that, I mean they have the same shape, size, color, taste. They weigh the same. Everything about each apple is identical to every other apple. We'll talk a little bit later why that's an important assumption, because a little bit later, we may come back and relax that assumption. I'll use that term from time to time, relaxing an assumption. What that means is we withdraw the assumption or we allow it to vary somewhat. And we think about what the implications of the variation of that assumption will be on the implication. That's how we're going to find out whether these assumptions are consequential or inconsequential in the end. And a lot of these are thrown in here because we're trying to keep the model simple and to make sure that we get obvious results or implications that we can draw from the example that we're building, the model we're building. Okay, third assumption. We're going to assume that Smith and Jones received utility. We'll use the term utility to refer to the happiness that they receive from consuming apples and oranges. So that's our first. We're imagining that Smith and Jones get happiness when they consume an apple and orange. Okay, this should be uncontroversial, but we're including it to be explicit and to say exactly what we need in order to make this story work, this model work. Now the next assumption, it's actually a little bit more iffy. Smith and Jones know their preferences for oranges and apples, and what that means is that they know exactly how much utility they're going to get from any possible bundle of oranges and apples they consume. So hypothetically, Smith might get 5 oranges and 5 apples at some point in time. And at some other point in time, Smith might get 3 apples and 10 oranges, some different combination. Well, we're going to imagine that Smith will always know which bundle of goods he likes better or prefers less. Or sometimes they will prefer them equally and get as much utility from one bundle of goods as he gets from another bundle of goods. But the assumption we're making here is only that they know how much happiness they get from different bundles of goods. Okay, this too is an assumption we're going to relax a little bit later, and we're going to think about what happens if you don't know your preferences perfectly and what kind of outcomes might arise in that circumstance. I want to highlight right now here, though, and I'll mention this again on and on. Our understanding of the economic system is really critically dependent on a simplified model in the first instance, but also what happens in that model if we relax the assumptions one by one at a time. So we're going to get a sense of how important these assumptions are to the result of the model by first constructing the model, seeing how it works when all the assumptions are valid. And then we're going to go back and start looking at what happens if we change some of those assumptions a little bit. How does that change the implications of the model? Now, we're going to imagine that Smith and Jones's preferences have 2 characteristics. I'll mention now, we're incorporating these characteristics because we think they're an accurate reflection of the real world in many circumstances. Maybe not all, but in many. So the first assumption about Smith and Jones's preferences are that more goods are better than fewer goods. Okay, first assumption here. More goods are better than fewer goods. And that's true for most things. Most of us would like to have more things rather than fewer things, and we'll be happier if we have an abundance of goods rather than if we have just a few. So getting more is better than having less. The second assumption is a little bit harder to understand. And so I'm going to take a few minutes to talk about it in more detail. We're going to assume that there's diminishing marginal utility in consumption of both goods. So consumption, we might say, exhibits diminishing marginal utility. All right, let me explain what that means. Actually, before I do that, let me go on with the last two assumptions, which are easy. We're going to assume that Smith is endowed or is given at the start of the exercise with 10 oranges. That's it. And Jones is going to be endowed in the exercise with 10 apples. So they're going to come to the marketplace with a fixed amount of goods. We're going to call that fixed amount of goods their endowment. Again, it's what they're given at the start of the exercise or for the model. All right, let me talk about diminishing marginal utility and what it means. And let me emphasize again something I mentioned last time in last lecture, which is we're saying Smith receives utility in consuming apples, for example. But I mentioned earlier that we don't really even know how to measure utility. Like Smith himself or myself, I can't tell you how many units of happiness I get in consuming 1 apple or 2 apples or 3 apples or whatever. So, but we have to have some sense of what we like more and what we like less. So this is an issue that actually goes back in economic modeling about a century or so, where individuals were very concerned about whether it was necessary to be able to put a utility value on the consumption of different amounts of goods. This is called cardinal or numerical utility, or whether it only mattered whether you could order your good bundles and say, I like this one better than that one. I don't know how much better, but I do know I like it better than that. And it turns out that most of, if not all of economic analysis goes through if we only assume that people can rank order their preferences or their bundles. They always know which is better than the other, even if they can't affix a particular number or utility value to the apples or oranges they're consuming. All right, so that's an aside. It's an issue we're not going to get into the details of, but I'm just highlighting it to show you some of the complications that economists think about carefully. All right, so let's imagine there is a way of measuring happiness and that we measure it in units of utils. So I'm using utils, as economists often do, as a simple version of the units that we measure happiness in. And we're going to imagine that Smith gets a certain number of utils of happiness with different amounts of apples that he may consume. Now, I will also point out that at this stage, even though he comes to the market with 10 apples, or I'm sorry, he comes with 10 oranges and no apples, what we're doing here is kind of a hypothetical because we don't yet know how many apples he's going to end up with. So we're speculating. If he had 0 apples, for example, we would imagine he gets 0 units of happiness. He's just not happy with no consumption. Let's imagine if he gets 1 util of 1 apple in consumption, hypothetically, that he would get 20 utils of happiness. Let's suppose if he consumes 2 apples in total, he gets 38 units of happiness, utils. 3, 54, 4, 68, and so forth. Now, I have created this preference function, if you will, in a way that exhibits diminishing marginal utility. And to do that, we have to go over here and look at marginal utility on the far right side. Now, marginal, first of all, marginal means change in. Marginal means what is the change in utility? And now we have to ask, change in utility given what? Well, it's the change in utility given a change in the quantity of apples consumed. So marginal utility, I could write it as this way, is the change in utility given a change in the quantity Q of apples that are consumed. It's the ratio of those two. Delta is a mathematical term representing the change in something. So the change in utility given the change in the quantity of apples consumed is how we would measure the marginal utility of apples. So MUA is equal to the change in utility given the change in the quantity. Now, let's measure it here. And you know, sometimes we're going to go, what is the change in utility that happens in moving from 0 apples to 1 apple? The answer is that the change in utility is 20. So this is actually coming by 20 divided by 1 additional apple that's consumed. The marginal utility of apples in consuming that first apple is 20 units. Get it? Now, the next marginal utility of the next unit, moving from 1 to 2, is also the change is 1 unit. The change in the quantity of apples is equal to 1. But here, the change in utility is equal to 18. So we take 18 divided by 1, and we get the value over here. 18 is the marginal utility in consuming that second apple. Third apple, again, 1 more unit of apples consumed gives 16 additional units of utility. So the marginal utility is 16, and so forth and so on. Now, marginal utility is listed here as a schedule, 20, 18, 16, 14, as we increase the number of apples. And notice that the value of marginal utility falls in value, 20 to 18 to 16 to 14. So that's where diminishing marginal utility is represented. Marginal utility goes down as the consumption of apples goes up. All right, so strictly speaking, that's the definition of marginal utility. Strictly speaking, diminishing marginal utility means that the marginal utility falls as the level of consumption of a product increases. All right, now, practically or intuitively, why are we including this particular assumption? We're including it because it seems to reflect what people actually experience. And I present this issue sometimes in the following way. Imagine that you're presented with a bowl of M&Ms, and you really love chocolate, you really love M&Ms. And your inclination, of course, is to take a handful, and let's measure M&Ms in handfuls. So the first consumption you take is a handful of M&Ms, and if it's your first chocolate of the day, you know, your mouth bursts with the flavor of chocolate, and you love it. It gives you happiness or utility because you're consuming chocolate. So what do? You take another handful of M&Ms. The second handful of M&Ms doesn't quite give you that first burst of chocolate flavor like you just had, so it's giving you more pleasure, but maybe not quite as much pleasure as the first handful. Take a third, a fifth, a sixth handful of M&Ms, and we all kind of know from our own experience that if you keep eating chocolate over a short period of time, you're going to start to feel like you're eating too much chocolate. You're eating too much, you're consuming too much sugar, it's not good for you, it might affect your skin complexion, it might, so your level of satisfaction with each additional unit of consumption of M&Ms is likely to diminish as your consumption level increases. Now, it might even become negative at some point, right? So it might get to a point where your stomach starts to churn a little bit and you're feeling a little bit sick because of the M&Ms. And if you continue to take another bite of M&Ms, another handful, you're just going to get sicker and your utility will go down, maybe even becoming negative. Now, if it did that, then we're violating this first assumption that more is better. Because now we've reached a stage, what economists would call satiation. We've reached a limit of how much utility you can get in the consumption of a good. And now additional consumption is actually going to make you worse off. That could happen in a realistic setting, but we're going to ignore that particular issue because we're just going to keep it simple. We're going to make a simplifying assumption that more is always better in the context of what analysis we're going to do that's coming forward. Okay, now, I didn't highlight this first point, but let me go back and do it. More is better is true in this particular example. Okay, let me go back to this first assumption that's also represented here. More is better is true because as apples increase, utility continues to rise. So notice, in moving from, 1 apple gives 20 utils, 2 apples gives 38 utils, 3 apples give 54. So as we increase the quantity of consumption of apples, it continues to go up. So more apples is always better than fewer apples in the schedule that I'm presenting here. But marginal utility goes down. The additional utility you get from each additional apple goes down as your consumption increases. All right, so again, we're including these assumptions because they seem to reflect most circumstances that exist in actual people's experiences of the consumption of goods. Let me add a couple of more assumptions that we're going to make in this particular pure exchange model. Again, to be complete, and I'm going to talk about the importance of each of these as we go along. So the next assumption, Smith and Jones seek higher utility. That means they want to be happier. This is what we would call a behavioral assumption. Now we're making an assumption about the intentions or the desires of the individual agents that are in our particular model. And we're going to imagine that they are self-interested. That is, that they only care really about their own individual utility. They're not thinking about what the other person is feeling, whether they're going to be happier or not happier. They're only interested in themselves. And we're going to introduce that as a key assumption here. Now, again, may or may not be true in the real world, is true in many circumstances, But for the purpose of the model, we're going to make the assumption that it is always true for Smith and Jones. They seek to get higher utility if they can achieve it. Now, later on, a little bit as we progress through this model, we're going to introduce a stronger assumption about their behavior, and that is we're going to say they attempt to maximize their utility. Right? And then we're going to think about what the implications of that stronger version of the behavioral assumption is. So this is something else we do in modeling, is we sometimes will have different versions of the model which correspond to different assumptions that we're making about behavior or different aspects of the model itself. That often makes it difficult to know when we're, for example, inside the pure exchange model and when we've now moved to some other model that should be given a different name. And that's a complication, a problem in economics that I know I've always dealt with and you will deal with as well. But be aware, that's what we're doing. Now, next assumption, Smith and Jones are willing to engage in mutually voluntary trade. Right? So they're willing to come together in the marketplace and actually consider trading with each other. We're going to think about the implications of that going forward. Now, another assumption that's very important, and I'm going to broaden this and describe it a little bit differently later on. I'm going to call it perfect information. And that's something we're really going to imagine in the first step here for Smith and Jones. We're going to imagine that they have perfect information that they need to make appropriate decisions in this model. So one of those aspects is they know perfectly the quality of the other's goods. So Smith comes to the market with 10 oranges, but he's going to trade them for apples. We need Smith to know exactly how those apples are going to affect his utility in order to make the appropriate decision. He has to know the quality and the taste and everything that he needs to know about the apples. He needs to know them perfectly in order, in the end, to guarantee the result that we're going to demonstrate here. Right? Now, that's something we're going to relax a little bit later on. But there's another aspect of perfect information that's incorporated already, and that is that they know their preferences. They know what their likes and dislikes are between apples and oranges. And they know that perfectly as well when they come to the market. Okay, so that's the aspect of perfect information that we're incorporating here. Now, there's some implicit assumptions that we make, and this is always true of models because it gets tiresome to try to write down every assumption that you're making. This also is a particular problem that arises in modeling because sometimes we make implicit assumptions, and by virtue of not mentioning them, we sort of forget about certain important aspects. Sometimes models are improved upon because someone looks at the model and says, hey, wait a minute, aren't you implicitly assuming this is going on and you haven't mentioned it or thought about the implications of that and it affects what the outcome will be? And if the answer is yes, well, then the model can be improved by explicitly introducing the assumption that's necessary to get the results that are being displayed. Okay, so let me give you an example in this context. We're going to imagine that Smith and Jones are humans. Now, we kind of already did that by saying they get utility from the consumption of apples and oranges, and they're willing to trade voluntarily. Remember Adam Smith's quote from The Wealth of Nations last time, though, where he says, nobody ever saw a dog trade a bone for another bone. Okay, so I didn't say Smith and Jones are humans at the start, but we infer that. We just sort of accept, of course, we're talking about Smith and Jones being two human beings and not two dogs. But again, the fact that we didn't mention it makes it an implicit assumption. It's there, but I didn't explicitly state it at first. Now I have, so now you know it should be true. Or Smith and Jones can meet with each other in the same location called a market. We imagine they have the ability to get together, discuss what's going to be called the terms of trade with each other and to trade with each other. And then one thing we forget about sometimes is that, especially in this world of international trade, that they've got to be able to communicate with each other, to talk to each other. What if they don't share the same language? How are they going to try to say, hey, I've got this stuff, you've got that stuff, let's trade with each other? What if they speak different languages and they can't effectively communicate? Well, guess what? That might affect the outcome. I didn't mention that because we just sort of take it for granted. Okay, of course they're sharing the same language, and of course that's true. But the fact that I didn't mention it at the front, and most people will not mention it in presenting this model, it's still an assumption that's there, but we have, by not stating it, made it implicit instead of explicit. Right? And sometimes that will happen, and you should be aware of that particular complication.